welcome back. Let's concentrate on assignment 1B. What we are trying to do here is develop a Python program to check whether given number is palindrome or not, and also count the number of occurrences of each digit in the input number. Okay. So what we are trying to do here is we are accepting a palindrome, or non-palindrome, and then we are printing. If it is palindrome, we are printing palindrome. If it is not palindrome, we are printing it is not a palindrome. And we are also counting the number of occurrences of each digits in the input number. Let's say I'll take a notepad. So it is like this. If somebody enters 1 to 1, is it a palindrome or non-palindrome? It's a palindrome, because when you 1 to 1 you reverse it, you get back 1 to 1. Next example is 1 to 1 to 1. Whether it's a palindrome or not, it's a palindrome, because if you reverse it, you get back the same number. Okay. And if you see here, in this example, 1 has occurred 3 times, 2 has occurred 2 times. That's what they want. Okay, that's what they want. The way we do it is let's start with main. Okay. You obviously know digits in decimal is 10, because you start from 0, you go up till 9. So 10 digits are there. So the way it is done is you say int, okay, input, enter the number. So you prompt the user to enter a number via input, and then you cast it to int. Okay, we accept only integers, because palindromes that you want to check is for integer numbers. And then taking this number as a input parameter, we know is palindrome. So let's go to is palindrome code. The way we do it is if there are 3 digits, let's say, one by one we go on taking the digits. So if it is like this, 1 to 1, the way logic is, first you take 1, then you take 2, then you take 1. Okay. And this one you move it here, 2 you retain it here, and 1 you take it here. How do we do it? By reversing. The logic to reverse it is here. Okay. First, the passed number you store it in temp. Okay. Reverse, you start with 0, and while number is greater than 0, okay, passed number is 1 to 1, let's say, digit is equal to num modulo 10. Okay. So if it is like this, when you do 1 to 1 modulo 10, you get 1. Okay. That is this one. And then rev is equal to rev star 10 plus dig. Okay. So the way you do it is in the very beginning rev will be 0. So 0 star 10 will be 0 again. Dig will be 1. So rev will be 1. Okay. And then you divide this 1 to 1 by 10. Okay. Well, num divided by 10. Okay. So when you do like this, you get 12. Okay. 12. And then you check here, this is a while loop, still in the while loop, you get 12, and then you come back here again. Now dig is equal to num modulo 10, that is 12 modulo 10 is 2. Okay. Rev we had 1, right? Okay. This rev 1 star 10 is 10 plus dig is 2, so this becomes 12. Okay. Next, what you do, 1 will be left out. Okay. Num equal to num divided by 10. Again we come back here, still it is greater than 0, so digit will be 1. Okay. So this is rev is equal to 12 star 10, that is 120 plus 1, 121. Okay. Num becomes 0, obviously. So now 121 is equal to 121. Yes. So we return 2. So when the value is entered as 1 to 1, it is a palindrome. If it is a non-palindrome, let's say 1 to 3, obviously we return false here. Okay. So next is let's concentrate on palindrome first, and then if we want to count the number of individual digits, the way it is done is we create a scratchpad called empty dictionary. So here Dictionary is like this, okay? If you point at dictionary, you will get. So dictionary, you create an empty dictionary. Zero digit has occurred zero times, one digit has occurred zero times, two has occurred zero times, three has occurred zero times. You assume like this. Yeah, it should end here at 9. I have written 10. This is not correct. This should be deleted here. Let's delete it here. Yeah, obviously digits will be till 9 only. So yeah, okay. You create an empty dictionary. So with all digits initialized to 0, and temp is equal to number. Whatever number is passed here, you take it as temp. And while temp is greater than 0, while temp is greater than 0 here, okay, you go on extracting individual digits. Okay. So let's say if somebody has passed 1 to 1, again let's take the same example. First, dig is equal to 1 to 1 modulo 10. Okay, 1 to 1 modulo 10 is 1. Okay, so the way it is done is dig is 1, dictionary 1 is equal to dictionary 1 plus 1. Okay, why? Because there is a digit 1, so we should increment this value here. Okay, this 0 becomes 1. Then we divide it by 10, so it becomes 12. We start with the loop again. Okay, this time dig is 2. Okay, dig this we incremented by 1. Then temp is equal to temp divided by 10. Okay, again it becomes 1. Okay, so that 1 we take it here. Okay, and then 1 modulo 10 is 1 again. Like now this dictionary dig we incremented by 1, so it becomes 2. So this is like once somebody has passed 1 to 1, the in 1 to 1, 1 has occurred 2 times, so this is 2. Okay, and 2 has occurred once, this is 1, so rest all will be 0. I think you got it. Okay, let's run this program. Yeah, let's run this program. Okay, first let's enter a number 1 to 1. Okay, press enter. This is what you will see. In 1 to 1, 0 has occurred 0 times, 1 has occurred 2 times, 2 has occurred 1 times. Rest all are 0. Okay, let's run the program again. This time let's feed a non-palindrome. Okay, first it printed it is a palindrome. Let's run and feed a non-palindrome number. Okay, non-palindrome number, let's say 1 to 3, right? 1 to 3. Let's press enter. It is not a palindrome. This is important information. So it should print not a palindrome. 1 has occurred 1 time, 2 has occurred 1 time, 3 has occurred 1 time. Okay, so these are two simple assignments that we have covered as a part of assignment 1. So both of these programs will be downloadable for you. You can run them at your convenience, modify the program, or have the prints in between to understand how these programs are working. Uh, yeah, that's pretty much it. Pretty much it. So 1A, 1B, both are complete. So both will be downloadable, as I said earlier, in the Udemy download section. So with that understanding, yeah, let's meet in assignment 2 later. Okay, thank you.